Isn't that amazing? Huh?
I don't know. Still too bright over there. You guys see, we're going to want some contrast. I like the microscope. We're going to want to see this. Oh, yeah, that's good. Okay, who's done histology before? No, nobody's ever looked at tissues? I mean, you've looked at what under the microscope before? Cheek cells. Okay, that's fun. Pond water, maybe. And yeah? Okay, but not tissues and identifying tissues. All right. Well, my experience is that when students encounter histology for the first time, anatomy and physiology students, is they're really frustrated by it. They're like, I don't know what I'm looking at. It's purple or it's pink, and I don't see anything. I don't know the top or the bottom. What do you want me to look at? And then usually you'll call me all over and be like, look what I found. And I'll be like, that's a hair. That's not what we're looking for. So this is just my disclaimer saying it's okay if you're frustrated for the first little pass with this, because it takes a little bit. Even if you're comfortable using the microscope and focusing it, it does take a little bit to start to orient yourself with what are you actually looking at, what are you looking for. So I have built this lab to have like 2 or 3 full sessions where we will be looking at this, and then you can also be studying this at home, looking at your textbook. Google image searching is super powerful for doing histology. Like if you're like looking at your slide and you're like, I don't know if I can really see my ciliated pseudostratified columnar epithelial tissue that I'm supposed to be looking for. Okay, you can Google image search that, and it'll show you so many other versions of it that you'll be able to identify it on your own slide then after that, right? Another thing is that you can also use your cell phones and put them up to the eyepiece, the ocular, on these and take pictures, take your own pictures, right, of these slides so that you can mark them up or airdrop them to everybody in lab or whatever. All right, so this is my analogy for how I try to teach students to look at things under the microscope. So I think so we have the 4x, the 10x, and the 40x powers, right? And I just told you we're not going to use 100x because we don't really need it, and it's oily. Okay. So this is kind of my analogy. So imagine you're in anatomy class, right? And I'm telling you to go find the goblet cell or the chondrocyte in the cartilage tissue, right? So the analogy would be, I am asking you to go find a tree in the forest, right? Cool. But you know, right, that if you're standing in, I don't know, the desert, it's going to be hard to find a tree in the forest. Or if you're out on a kayak in the ocean, okay, it's going to be hard to find a tree in the forest. Okay, so this is the way that I would like you to use the scope, is to think of 4x as kind of like being on the space station. Okay, and here's Earth, right? And you were told to go find a tree in the forest. You're not really going to be really advised to go looking here in the ocean, right? So always kind of like put yourself up at the space station and look at the slide and be like, all right, I think this is maybe where I would find a tree in the forest, right? Versus, are you okay? All right. So then you hop on an airplane. Okay, that's going to be your 10x magnification. This is Alaska Airlines. I can't remember the flight number. This is my photo. The other one wasn't my photo. I didn't take that. Just making sure. I took this one, okay, over spring break when I went to Washington State and Olympic National Park. Okay, so this is Seattle right here, and this is the ocean, and that's where the forest is. Okay, so 10x I kind of view that way. If I'm flying in my airplane, I can actually start to see some different things where I'm like, oh, this is the city here, this is the ocean here, I think the forest might be over here, right? And then you go down or up in magnification to 40x, and you're actually on the ground. I call it like boots on the ground. now you're landed on the planet, okay, at 40x, and hopefully, if you flew your airplane, right, you started at the space station, and then you flew your airplane over a place that looked like a forest, and then you got out of the airplane and started walking around, you're going to be amongst trees, right, and you're going to find the trees. But if you are standing there and you're like, oh my God, I don't see a chondrocyte or whatever, and I come over there, I'm always going to tell you, right, if you can't find what you're looking for, to go back to the space station, to go back to 4x, and kind of look around a little bit and make sure that you're not drilling all the way down when I come over and you're at 40x way over here, because you're never going to find the trees over here. Does that make sense? So if you're looking at an epithelial tissue, which we know is a covering and lining tissue, you're looking for one of those, but you're down deep in the center of the tissue on the slide, okay, you're going to be in the wrong place. Because epithelial tissues are always on the edge of what you're looking for, because they're a covering or a lining. So something that got sliced and you're looking for epithelial tissue, most often it's going to be on the outside edge. But if you're way down inside the pink area on the slide or the purple slide going, I don't see stratified squamous epithelial tissue, right? I'm going to be like, okay, well, back it back up. Okay, if you're looking for the edge, go over here where there's an edge, right? Or if you're looking for a tree, go over here where it's green and forest-like possibly. Or if you're looking for a dolphin, okay, don't be over here, look over here, right? So then you go to 10 and you're like, oh, fishes are going to be here, buildings are going to be here, right? And then you zoom in and you find your phone, okay? Often, a lot of students get lost looking for things, and all they need to do is just kind of change their perspective back up again and go back down again, right? If we were to do 100x, it would be like this, right? This little like kind of macro shot of the mosque. Cool, but you're going to have a hard time finding trees this way as well, right? Because you're going to be so drilled down that you can't see what you're looking for. So this is one reason why I don't use 100x. Are we okay with that analogy? Does anyone have any questions? All right. So there is an Instagram or a blog. I heard this was, and I follow. It's really cute. It's all kinds of funny things that you see when you're looking under the microscope, or things that, you know, it's kind of like Rorschach of the clouds. You know, where you're like, I think I see a heart here. All right. So in the human body, there are 4 types of tissues, right? If I were to take you apart and put you into, separate you out, I would put you into 4 piles, okay? Or every part of your body can be considered one of these 4 things. You are either epithelial tissue, which is covering and lining as a generic kind of function of epithelial tissue. There's going to be lots of different kinds of epithelial tissue depending on where we are and what job needs to get done, right? Structure indicates the function. There is connective tissue. Connective tissue's job is support. What that support looks like can vary, right? Just like in life, right? I just need support, right? But there's different kinds of support, right? Bone is a firm support. Blood is a totally different kind of support. It's supporting you by bringing oxygen to you and nutrients. So connective tissue is a big class. The other 2 classes are muscle tissue, which will function in movement of something, depending on the type of muscle tissue. If it's skeletal muscle, that's movement of your body, right? But if it's smooth muscle, it's movement of food through your intestine, movement of blood through your vessels, movement of the baby out of the uterus, movement of urine out of the bladder, whatever movement, okay? And cardiac muscle is also a movement tissue, and that's specifically for moving blood through the heart. And then the last tissue type is nervous tissue, and that's going to be specialized tissue for control, maintaining homeostasis essentially, right? So the nervous system will function in monitoring and controlling everything. So the 2 that we are most interested in for this lab is epithelial tissue and connective tissue. So here's how epithelial tissue is classified, okay? It's classified by its cell shape, type, and it's classified by how many of those cells you have. All right, so there are 3 cell types in epithelial tissue, coverings and linings, okay? They are going to be squamous shaped. Those are kind of like fried egg or football, flattened football shaped cells, squamous cells. They're very thin, which makes them sometimes hard to see. Okay? There's cuboidal cells that are equally tall as they are wide. They're very symmetrical, roundish, cubish. Okay? And then columnar cells are taller than they are wide. They're like columns. By the way, the nuclei of all of these cell types will typically mimic the overall cell shape. So in a squamous cell, the nucleus is all flattened. In a columnar, it's taller. In a cuboidal, it's nice and symmetrical. Doing okay? Then, remember I said it's how many of those cells. So we have squamous, cuboidal, and columnar. Then we can have either simple, which means there's only one cell layer thick of that cell type, or we can have stratified. Strata means layers. So stratified means there's more than one cell layer. Can be hundreds, or it could just be two. Okay? So that means we can have simple squamous epithelial tissue, and we can have stratified squamous epithelial tissue. We can have simple cuboidal epithelial tissue and stratified cuboidal. We can have simple columnar and stratified columnar. This guy over here, pseudo-stratified columnar epithelial tissue, is a sneaky one. Okay? It's going to give you the impression that there's multiple layers of cells because the nuclei are all over the place. They're not all like lined up in a row. But all of the cells are in contact with the bottom layer, the basement membrane down here. Okay, so it's like, even though you can't see right here this cell, it actually does go all the way down. So there really only is one cell layer thick. They're just all kind of different shapes. It's the way they orient themselves. So it's called pseudostratified. Typically this one is going to be ciliated as well. So it'll be called ciliated pseudostratified columnar epithelial tissue. So if form and function, okay, are complementary to each other, what would be your guess of the function of a simple layer of flat cells? What would be the job? What would you want to do with those cells? Would you want to protect important organs and tissues with one cell layer of really baby thin cells? No? No? Okay, what would you want to do with?
Lining?
Lining, sure, just like a delicate little lining. Sure, so the inside of our blood vessels has this delicate little lining. Actually, damage to this delicate little lining inside your blood vessels is the basis for heart disease. By putting cheeseburgers in there, okay? All right. How about passing things across? Like if I need to get something from here to here, and I always have to go through a cell. We learned that, you always have to go through. But if I only have to go through one cell layer and he's nice and flat, then I would probably be pretty efficient at absorbing or secreting things across there, right? So these guys are found in the airways of our lungs, the alveoli of our lungs, where we're passing oxygen and carbon dioxide back and forth. We're doing it across one thin cell layer. Stratified squamous epithelial tissue can be like hundreds of squamous cells stacked on each other. In fact, they're layered a little bit like brick and mortar, like really end to end, really tight, right? So that would not be very good for us to have in our lungs if we're trying to get some oxygen, because you don't want to cross through tightly connected 100 cell layers thick just to get your oxygen, right? So where do you think we would have this? What would be the job of having like this brick and mortar covering or lining? Protection. Yeah, where do I have protection? The skin. Yeah, so the skin is going to be keratinized, stratified squamous epithelial tissue. We have non-keratinized or more moist stratified squamous epithelial tissue everywhere we need protection inside the body. So think about your esophagus. as you're swallowing like Doritos and nachos, okay? Like they're scraping their way down. You better have multiple cell layers there, okay? The vagina is another example of a place, a portion of the rectum. Those, an oral cavity, I just said, esophagus. Those have stratified squamous, but they're more of a moist, non-keratinized version. And that'll be chapter 5 when we talk about skin. Question? Okay. So one characteristic of epithelial tissue is that it has a top and a bottom. There's like a right side up and a wrong side or whatever. There's an attached portion, the part that's attached to whatever is underlying it, and there's an exposed or free or apical surface. Okay? So everything that's coming in contact with your coverings and linings is touching the free surface, the exposed surface out here. Even if it's one cell layer thick, there's a top, the part of the cell that's exposed, and then there's the part of the cell that's attached. Okay? And it's attached to connective tissue, which supports epithelial tissue. All kinds of different types of connective tissue. Okay? But connective tissue down here is supporting the epithelial tissue that's attached. They create a basement membrane here. Yeah?
Would you mind saying that one more time about the parts that are exposed and not exposed?
Apical free surface is exposed to everything, whatever. Right here, it's the air.
Yeah.
In my mouth, it was Doritos. Okay. In my intestines, it's the chyme, you know, that my stomach is squirting out through my duodenum, right? And then in my duodenum, I've got to get all the nutrients. All of that fluid is sitting on the apical surface of simple columnar epithelial tissue that's lining my small intestine. And so forth. In the little ones inside the blood vessel, right? The simple squamous inside the blood vessel, the endothelial lining. There's an exposed part of the cell, the one that's in contact with all the platelets and red blood cells and white blood cells, and then there's the part of the cell that's attached to the connective tissue that's attaching it then to its smooth muscle. We're doing these slides again as a formal lecture, okay, in class. We're going to go through this again. In fact, in my role, I'm going through this so many times this week. It's kind of ridiculous. So I'm going to keep going. I'm just giving you kind of the framework so that you can hit the microscopes and actually kind of get an idea of what you're looking for. Okay. But we will hit this in a more formal sense. All right, so different types of epithelial tissues. So simple columnar, simple colloidal. All right, so you're like, okay, let's see. So simple squamous epithelial tissue, one cell layer thick of squamous cells. These are found in the air sacs of the lungs, lining the blood vessels. In fact, capillaries are simple squamous epithelial tissue, just one layer. Okay? So if you did cheek cells, like you guys told me, those are squamous. They're not simple, but they're squamous cells that you scraped off from your oral cavity and put on a slide, right? So they looked maybe a little bit like this, like out floating around or whatever, or like this, okay? But in our slides, we're doing more tissue sectioning, so you don't just have free-floating squamous cells in the body when you slice a tissue like that. So the squamous cells are going to be these little flat, 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 okay? Not so much finding stuff down here that's covering and lining. You can, definitely, if you can find a blood vessel or something like that. But out here is the surface, and that's where your epithelial tissue is going to be. So here's another example. This is a structure in the kidney called the glomerulus. It's a little bit like a baseball in a glove. Okay, so that glove is your filtration membrane in your kidney, and so these guys have simple squamous epithelial tissue lining the glove. All right, so you can see them here, here, here. This is a blood vessel. Here, 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 here. Here's a blood vessel. Here, 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 here. Okay, so what do you think? Let me see. You see some simple cuboidals right here, and that's true because this is from the kidney. So these are the tubules in the kidney. What? Right there, simple squamous. So this is where I tell you that when you look at your slides under the microscope, you're going to see all kinds of things on there. It's not like only simple columnar tissue that was on this slide. right? It's going to be a section through the intestine, and therefore you're going to have smooth muscle, you're going to have connective tissue, you're going to have a simple columnar that's lining, and so forth, right? This is a slice through the kidney, so we're going to see all kinds of things on there. Yeah?
How come it looks like stratified? It looks like multiple layers.
There are not multiple layers.
1, 2, 3, 4,
Whatever. Where's our multiple layers?
Oh, never mind. I was thinking of bigger.
Up there? Yeah, that's tissue we're not caring about right
No,
now.
like the bigger structures that the cells are within.
This?
Yes.
These are tubules. So you can think of this like little straws on cross section. So this would be the plastic of the straw. This is what goes inside the straw, which is your pee. Or filtrate. Okay. Simple cuboidal. Here we go. Kidney tubules. 4 of them. See them? These ones are easy peasy, you guys. Can't mess this one up, in my opinion. Okay? To me, it's just like easy, easy, easy. Cool? All right. So this is me telling you again, on your slides, probably, possibly, 100%, you will see multiple different things on your slides. And sometimes you'll see things that we can't identify because I'll just call it connective tissue to be safe. Simple columnar, line the GI specifically. Okay, so this is a cross section of the GI. These are villi, or finger-like projections that you have inside the intestines. Okay, so this is where the blood vessels live, where they're going to take everything that you ate and bring it to the liver and so forth, or the lacteals, the lymphatics, whatever. All the vessels are in here. Okay, so lining these fingers. So sometimes people, when they see this, they think this is columnar, this is columnar, this is columnar. No. Okay, these are villi. Here are the columnar right here. Lining, 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 lining. Okay? So the columnar are in contact with food, which is in here, and goes to the columnar. We're starting to see these little bubbles in this epithelial tissue, which I'll tell you about more detail later, but those are going to be called goblet cells. They're a gland that's secreting mucus into the intestine, or gut loop, as I like to think of it. Okay? Again, I heart has the 3 tenors performing a small bowel movement. All right, so that's bowel. Simple columnar, seeing these little goblet cells in there as well. Cool. You're gonna call me over there and be like, what's this? And I'm gonna be like, connective tissue. There's a really good image of a goblet cell, like literally putting mucus out onto the surface. All right, those pseudostratified are kind of going to give you the appearance of having different levels. Okay, these guys are found in the trachea, respiratory tract. They are then often ciliated, and they have goblet cells. This is the point where I say, isn't histology kind of pretty too? Like, don't you think some of these images are pretty? I mean, I guess it depends on the stain or whatever, but I think it starts to be beautiful. You can see art in here. Okay. Cilia, 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 cilia. Pseudostratified columnar, goblet cell, goblet cell, goblet cell, connective tissue. Huh?
Are they going to do that image for those ones? Or will they do
Now I'm going to give you the slide, and you're going to go to the space station, and you're going to be like, okay, where am I going to find these cilia? Because you're not going to be able to see the cilia from the space station, right? Even from the airplane, you might be like, I don't know, like in Seattle. Are there trees over there? It looks kind of green, but you're not seeing the needles on the tree, right? You got to get down and hike in Olympic National Forest, right, or Olympic National Park, in order to see the needles on the tree, or the moss hanging from the trees, or whatever, right? It's going to be kind of like that. So you'll be waiting here. Right? So 3 different versions of ciliated pseudostratified columnar epithelial. Now we're in the stratified. Stratified squamous, like I said, is protection against abrasion specifically. And there's 2 different kinds, keratinized and non-keratinized. That'll be about chapter 5. And in chapter 5, we'll name the different regions of these strata. Like, we'll name the strata. Right? This will be the stratum basale, or the basal layer, and then so forth. Okay? So, we're not worried about that yet. But you can maybe see that there's little differences in these cells from down here at the basement membrane where they're born to out here where they're sloughing off. Okay. So, stratified squamous. By the way, the cell shape that you're most interested in on stratified is the outermost. Okay, because if you're looking down here, they might look a little cuboidal. Okay. But you can see over here in this one, there's the squamous shape. Down here, good. And here's from the foot. That's kind of cool. Pretty. Stratified cuboidal and stratified columnar exist in the body in very small and rare quantities. And I don't have slides for them, so we're not worried about it. You know they exist, but we're moving. Transitional is a stratified epithelial tissue specifically lining the urinary organs. Okay, so the ureters exiting the kidneys, the urinary bladder, and a portion of the urethra. This tissue is specifically designed to change its shape depending on how bad you have to pee. Okay, it literally is either, you know, relaxed or distended. Relaxed or distended. Right? So this is like a cross section on a ureter or something like that. So this is the transitional epithelium. To me, this is one that doesn't look like any other one. So that's how I know it. It looks like it might be stratified cuboidal, like kind of like how stratified squamous, but stratified cuboidal. But I know, because I'm smart and I listen to my teacher, that that doesn't exist. Okay? Stratified cuboidal does not exist. So this is, you're going to be like, ah, what is this? I'm going to say it's transitional. There is stratified cuboidal, but it's only 2 layers and it's rare in the body. So when you're looking at this and you're calling me over saying, this looks cuboidal, and like there's lots of layers, I'm going to be like, yeah, it's transitional epithelium. It has a little bit of that appearance. To me, it's more clear because the epithelial surface is bubbly. It's not smooth and consistent. It's like I don't know, bubbly. And I can see the basement membrane, and I can see there's multiple layers, and I know intellectually that there's nothing else that it could be other than transition. Let's skip over all the gland stuff for now. And then we start the connective tissues. Oh my God. How you doing? It's great, isn't it? Okay, connective tissues are either firm, just like support. There's either firm support or kind of loose support. Okay? So we have firm connective tissues, dense connective tissues, and we'll have loose connective tissues. And we will also have blood, which is its own kind. So the point is, all these connective tissues come from one origin, one embryonic source. And they differentiate into whatever kind of support they need to be. So the structural plan for connective tissue is different than that of epithelial tissue. Remember, epithelial tissue is just cell, top and a bottom, right? Okay. Over here, this is connective tissue. We'll just look. Okay? It's not cell. In fact, there's just random cells every so often, but there's a lot of extracellular material, extracellular matrix, fluff and jelly surrounding the cells. And we have fibers, okay, proteins in there, collagen and elastin, in different quantities depending on what type of tissue we're talking about. Okay, so the generic idea is that there's cells, an extracellular matrix, and fibers. So the first loose kind is called areolar connective tissue. This is super widely distributed in the body, you guys. This is like everywhere. You can think of this a little bit like the packing peanuts in your body. Like what is between your esophagus and your trachea and your carotid artery? What's filling those little cracks? Okay, areolar connective tissue. This is when you have swelling or edema, this is where the fluid is in your areolar connective tissue. It's not in the cells of your skin. It's not in the cells of your muscle. It's in the fascia or the connective tissue surrounding the organs. Loose areolar connective tissue. Very easy, in my opinion, to identify in our microscope. Yes.
So, like recently, I just burned my hand and gave myself a second-degree burn, and it like.
So it blistered.
Yeah. So would that be what that connective tissue was when it bulked up?
No, a blister from a second-degree burn or abrasion blisters is fluid buildup between. Yeah. So yes, it's in the areolar, but specifically the fluid is pushing the epidermis up, and the dermis is below here, which is a different type of connective tissue I was talking about. So you get a exudate or a secretion of fluid right here like that. That's a blister. So the skin is on top of it, the dermis is below it, and that's your blister like that. So it's not as much areolar connective tissue as it's like a immune system response to either heat or friction or whatever.
Oh,
Or
okay.
it's separating the epidermis from the dermis. Yeah.
Yes.
Blistering. Some of us use a different kind of packing peanuts, that would be me. Okay, and as you age, okay, the cracks in the spaces start to get filled in a little bit more with calories that I forgot to burn. Okay, also known as adipose tissue. Adipose tissue is a loose connective tissue. It serves support, right? Nutritional support and cushioning and all of that. Okay, so it's also in all the cracks and crevices. In certain areas more than others. Genetically determined. All right, so this guy to me looks like big white puffy clouds. Okay, big huge vacuoles full of Jimmy Johns. So, guys, Jimmy John's is bad for you. I don't know if you know that. Do you know that? Do you want me to tell you? The number 9 Italian nightclub is like having 2 Whoppers and a fry and a Coke. No joke. It's the bread. I don't know what they do, but they pack that thing full of like 2 days worth of calories. Or McDonald's. Reticular connective tissue is a loose type, and it's a network of support for your immune cells. It's specifically found in the spleen, bone marrow. I don't have this slide, so we're not going to be looking at it for lab on histology. Now we're into the dense tissue, so it's not just as much like jelly and packing peanuts and filling fluffy kind of stuff. Now we're going to have some more, the protein is going to be arranged, collagen fibers in this one are arranged like long ropes. There's still extracellular matrix, it's just not very fluid. There's still cells, but mostly it's collagen in big long ropes, or tendons and ligaments. These ropes have jobs. Attaching bones together, attaching a muscle to a bone, even attaching a muscle to a muscle if you're talking about an aponeurosis. Okay, so dense, regular means like parallel, wavy, connective tissue. This one's going to be sneaky because it looks a little bit like muscle. Dense, irregular connective tissue still has the fibers, but the fibers are kind of more irregular, okay, swirly, not as parallel. So this is going to be joint capsules and the dermis of the skin. This is dense, irregular connective tissue. There's a little blood vessel over here. Another little blood vessel. So what would that tell me? Money! Over there we go. You. All right, probably maybe adipose. Adipocyte. Sure, if it's lining the blood vessel that's going through the dermis. Again, nothing occurs just like all on its own out there. There's blood vessels in the adipose. This thing is full of blood vessels, all over the place. Form indicates function. Why would we have a crap ton of blood vessels going to adipose tissue? What's the job of adipose tissue? Yeah, energy storage. So in order to put the energy into the warehouse, you need a road going there. Okay, so blood vessels take the energy or pull. Hopefully more likely, but this America, y'all, it's usually packing the energy into the warehouse, not pulling the energy out of the warehouse. We've got that kind of messed up right now. Okay. For every pound of adipose tissue that you put on your body, okay, you are putting on miles worth of blood vessels to service that pound of adipocytes, okay? And you're like, yeah, who cares? Okay, so I'm putting some more blood vessels to service my warehouse, right? The problem is when you get to AP2 and you start learning about blood pressure, okay? As you increase the amount of pipe in the circuit, essentially, okay, you just increase the pressure in the circuit, right? And then you're gonna have problems because the pressure is gonna damage the simple squamous cells that are lining those pipes, and then they're gonna be susceptible to grabbing cholesterol that might be in your blood and putting that cholesterol into the wall, and then you're building plaques, and now you're on your way to heart disease and stroke. Yeah? All started with Jimmy Jones. All right, so this is skin. There's my stratified squamous epithelial. My epithelial tissue's at the surface. Generally, I mean, yes, you can find some epithelials down in here, but if you call me over here looking for stratified squamous, I'm gonna tell you to go back to the space station and find the edge, the coast. Like if you're looking for the coast, right, and you're all the way landlocked, you're not gonna find the coast. Right. So go out here, there's a stratified squamous. Down here is the dense irregular. Here's the epithelial tissue, here's the dense irregular. So this is skin, like epidermis and dermis, chapter 5. All right, cartilage, another firm type of connective tissue. And it's not so simple that we're just gonna look for cartilage, but we have 3 different types of cartilage. Just to make our lives wonderful. There's hyaline cartilage, that's the most prevalent cartilage in the body. That's going to be the ends of your bones and the ribs and your nose. Okay, it's called hyaline because it's kind of glassy, see-through-y. The extracellular matrix here, that instead of being jelly and liquidy, it's actually firm. There's cells and there's fibers. We just can't see as many of them in hyaline. What is a cartilage cell called? Chondro, right? Chondrocyte. All right, so cartilage cells are going to be called chondrocytes. Guess what a bone cell is going to be called? Osteocytes. Guess what a fat cell is called? Adipocyte. And so forth. Okay, so chondrocytes, they live in little cavities. That's how you can identify them really clearly. The cavities are called lacuna, or lacunae if it's plural, A-E. So chondrocytes living in lacuna is what you will see on hyaline cartilage. It's kind of furry. Cool. More connective tissue back here. And if this was a trachea, and I were to slice the trachea, okay, and I were, huh?
Oh, sorry.
Oh, I was like, oh my God, are you going there? Okay, if I were to, like, so I'm down on the ground. If I were to get up in the airplane, right, and look at the rest of the slice and see what else is here, and I sliced a trachea, what else would I have? Close. No. The ciliated pseudostratified columnar epithelial tissue with goblet cells that's inside the trachea, remember? Oh, you're like, wait, she said that? The esophagus was the stratified squamous. So if I slice the esophagus, I'm going to see stratified squamous and then smooth muscle, which is helping swallow Jimmy John's. I'm stuck on Jimmy John. I'm hungry. All right, elastic cartilage. I love it when life is like this. Elastic cartilage is found in the external ear and epiglottis. Got it. That helps with memorization. It's like a mnemonic. Okay? So it's like hyaline, but it's bendier. Your ear is bendier than your nose. Try it. Okay. It's got more elastin fibers, so much so that you can actually see them in the extracellular area. These guys are kind of cool. They always look like little creeper eyeballs looking at me though. This is another time for me to tell you that in our lab, we have multiple slides, so they're not always stained the exact same. They're not always made by the same company, and so forth. They're not always from the same critter. Maybe it came from a guinea pig versus a rat versus a monkey or whatever. Like, sometimes they're different, Okay, so looking at multiple examples, that's where the Google image search is really helpful. Because then you can see like the consistencies among them all, right? Like what are the characteristics of this tissue, no matter what color it's stained, no matter what the magnification. All right, fibrocartilage is the toughest cartilage we have. It's almost like a tendon or a ligament. I don't have slides for it, so we don't have to look at it. All right. Easiest slide ever on the planet to identify, in my opinion, bone or osseous tissue. Don't spend any time on this. Look at it and move on. We're coming back to it in chapter 6 and 7, okay? We're gonna have little osteocytes living in the kuna. But we'll name all of these parts when we get to those chapters, so don't get too hung up on it. Just be able to identify it as a connective tissue called bone. Blood, again, this is an AMP2 topic. You'll get to play and name all the white blood cells and count them and whatever. So for now, identify this tissue as connective tissue, blood, support. Just for fun, what do you think is this little flecks of randomness? Nope. Nope. Platelets. White blood cell, red blood cell, platelet. Plasma. Yep. Muscle comes in three types. Histologically, it's going to look a little bit different. Smooth muscle is going to be the one that looks a lot like dense regular. Okay? Because it's nice and wavy and parallel, okay? And it doesn't have what the other two types of muscle have, and that is striations. You can see, if you look real hard, there's little shadow stripes on this cardiac muscle tissue and this skeletal muscle tissue. See those? Like the fibers are running this way, which is great. They're multinucleate, but then there's little tiny little shadows or striations